In today's tutorial, we will focus on frames and machines. And if you are wondering about this picture, well, this is a frame and this is a machine. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today's tutorial will focus on chapter 6, structural analysis on frames and machines. So we have covered structural analysis on trusses before in the previous tutorial. So hopefully you have understood the difference between trusses and frames and machines, and today the focus is frames and machines. So as usual, we will be covering the previous exam questions from exam question in the past to help ourselves to prepare to similar level of questions that have come up in the final exam in the past, right? So the question that will come in your exam may be similar, may be different, but at least we have tried different type of questions from different semesters of final exams in the past. Hopefully it is going to prepare you much better, inshallah, right? So if you need to see the questions first and to select which question you want to look into in this tutorial, the PDF will be in the description box below. You can download it and see the questions, and you can jump to any question that you want in the timeline, inshallah, right? So I think without further ado, let's go and look at the first question. So this is the first question. So you have the diagram there on the bottom right, and the question goes, how many members are there in the machine shown in the figure? And then draw the free body diagram of for each member. The spring is compressed by 0.02 meter when the mechanism is in the position shown. The spring has a stiffness of K equal to 5 kilonewton per meter. And then part C, based on the free body diagram you have drawn, determine the force P on the cable. Clearly specify which free body diagram is the basis of each of your equation of equilibrium, right? So actually the question here, when this question come up, it is basically structured in a way so that it is to help you or the student to do step by step, right? So they say how many members, and then draw the free body diagram and then calculate, right? So some question in the exam will be in the format. Some will just ask calculate the force P, for example, and you have to know, you have to draw the free body diagram first, etc., right? So it depends on what happened in that semester and what is the preference of the lecturer, right? All right, so given that, look at the diagram first and identify how many members. So that's the first question. How many members are there? Can you see? It should be straightforward, right? You can count, right? So there's 1, there's 2, and there's 3, right? So hopefully you can identify the 3, right? And then draw the free body diagram of each member, right? So we will draw this, right? Okay, we have how to do this, because after we draw the free body diagram and then we have to calculate, right? So maybe I'll draw the free body diagram here and then calculate there. We will see. Okay, so basically you have 3 members, right? So you have on the top there something like this, right? The beam there, and then you have this thing here, something like this, right? And then the another member there. Where should I draw it? Okay, I'll draw it here, something like that, right? So basically this is ACF here, and then this is CDE, and then this is DB, right? Okay, this glare, is it? Is it better? Okay, so this is the 3 members, right? Of course, when you draw the free body diagram, first draw the outline and then draw all the forces and label it properly, right? So first thing first, just like in, of course not like, because in the trusses you have to try to identify whether there is any 0 force member, right? Because otherwise everything is 2 force member. But in this case, in frame animation, you have to identify whether there are two force member normally, right? So in this case, hopefully you can identify that there is actually one member that is two force member, which is member BD, right? So this member BD is two force member, right? So if it is a two force member, it's either in tension or compression, right? So in this case, logically, if you can imagine that, so it tend to be in compression. So, oops, okay, this marker is out. Okay, so if I assume it under compression, then the corresponding force here will be like this, right? So let's label this FBD, FBD, this will be FBD. Alright, is there any other two force member? No, right? So other than that, it's just what we have. So here we have P, and then at point C, you'll have X and Y component, right? Because this is pin connected. So let's say CX is like this, CY is like this, so it will be like this, right? CX, CY correspondingly. Of course, the direction is assumption, but sometimes you can guess, right? Because for example, if this P is like this, to counter the moment, this should be like this, something like that, right? But anyway, so you have, let's say here is AX and AY, and then yeah, another force is at P, right? And no, at F. And the question says the spring has a stiffness, so 5 kilonewton per meter, and then the spring is being compressed by 0.02 meter, right? So if the spring is being compressed, meaning it want to push back, right? So it is pushing down, and then the value, we know F equal to Ks, right? So K is, in this case, 5 kilonewton per meter, 5 kilonewton per meter, and then S is 0.02 meter, 0.02 meter. So you can calculate this. What will it be? 0.1 kilonewton, right? Okay, what else? So all the forces are here. So this is known, unknown, 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 unknown. Right? So how many unknown do we have? 1, 2, 3, 4, same. 5, 6, same. Right? So if you have 6 unknown, you can solve if you have 6 equation, right? So basically you have this free body diagram here, hence you have 3 equation here. You have another 3 equation here, right? This one is not useful because there's nothing can be calculated there, right? So you have 3 equation, you should be able to solve because you have 6 equation and 6 unknown, right? So for the free body diagram, of course, you have to have all of the other dimensions, angles, etc. So basically you have 30 degrees here, and then you have 150 millimeter. This is 150 millimeter. This one is 200 millimeter, right? And then this one is it 200 millimeter. This one is 200 millimeter, and then this length 800. Is it 800 from here? Is it? Yeah, from here. This is 800 millimeter. Right. So what we need to find in this question, it says determine the force P. So what we have is the value here, and we want to solve P, right? So from this diagram here, because then the idea is we want to find any value that can shift our calculation to that point there, right? So in this case, if I can get Cx and Cy, then I can solve for this one, right? But to get this, then how many equations do I have? Because here you have a simultaneous equation, that will be tough, right? So for question like this, because the rest is mathematics mainly, right? So it does involve a lot of exercises for you to get familiar with what kind of option or path of calculation that can help you to get to the destination that you want, right? So For example, because in this case you do not need this one, right? So I'm not interested to calculate this one. I need to calculate this, right? But if you calculate moment of this point about A, you will have in your expression x and y, right? So is there any way to get only one and then the other? So if you have in the expression of x and y, so that's where sometimes the advice is, if you do not know where to start, you just start somewhere, get the expression and see what you can do, right? So for example, if I label this as my free body diagram 1 and free body diagram 2, right? So from free body diagram 1, right? So let's see what can be done here first, right? So because I want to see what I can do here. So because mostly it will involve simultaneous equation anyway, right? So if I take summation of moment about point C, for example, because I just want to relate P and F, B, D, sorry. So then I will get, if I take if I take clockwise as positive, so I'll get P times 350 if this is in millimeter. So P times 350, and then minus, if this horizontally, F B D sine 30 degrees times distance of 200 equal to 0, for example, right? Okay, so is this correct? F sine 200. Alright, so maybe I'll just shift this so that I can express everything in P, perhaps, right? So let's say FBD, then it will be P times 350, then divide by shift here sine 30 degrees and then times 200, right? So can you calculate that? What do you get? (350) divided by 200 divided by sine 30, then you get 7/2 or 3.5, right? Okay, so you have 3.5p. Make sure you do not make that mistake. Alright, so FBD equal to 3.5p, right? So then henceforth you can just replace this, right? So for example, if I do still from free body diagram 1, summation of fx equal to 0, I'll get p minus fbd sine 30 and then plus cx plus cx equal to 0, right? But fbd I already know it equal to this one, so my equation can simplify between cx and p, right? So p minus fbd becomes 3.5p and then sine 30 degrees plus cx to 0, right? So meaning from here, okay, if I continue here, cx will be okay, so 3.5 sine 30 minus 1, right? 3.5 times sine 30 when bring over there minus 1 becomes 0.75 p. Alright, leave it there first, and then if you do summation of fy equal to 0, then you have fbd cos 30 minus cy equal to 0. So cy will be, if you plug in fbd with this one, 3.5 p and then cos 30, right? So or cy equal to, if you calculate 3.5 times cos 30. So basically you get 3.0311 p. 3.0311 p roughly, right? So basically what I have done, what I have managed to do here is actually Cx is already in term of p, Cy is already in term of p. So when I do this here, then this is in term of p already. So it is easier to correlate that number with p, right? Because in the end what we want is p, right? So that's what I have done. So do we have enough space? So I'll continue up there, I think. So from free body diagram 2, if I take moment about point A, okay, let's take clockwise as positive still. So about A, now you have 0.1 here, right? 0.1 times distance of 1000, is it? And then you get Cy, but it's counterclockwise. So minus, okay, I write first Cy times 200. Oh, where is it? 200, and then minus Cx times 200 equal to 0, right? This one and this one and then that one. All right, so if I replace all of this, so Cx is, so from here 100 minus Cy is Cy is 3.03, okay, so 3.0311 p times 200, and then minus Cx, so minus 0.75 p times 200 equal to 0. So if you calculate this, okay, I'm calculating on the go here. So 3.0311 times 200 and then 0.75 times 200. So you will get 756.22 p equal to 100. So after we have this, so it's just basically p equal to 100 divided by 756.22. Then it's 0.132 kilonewton. Right. So that will be your answer if that is the value that is being given, right? So this spring force here will produce that P there, right? So this is not the only way or the only path of calculation, right? So it depends. You can start from here, from there, but this is purely mathematical part, right? So the static part is until you draw the free body diagram and establish all the parameters. After that is just, you know, basically applying equation of equilibrium. That's statics, but the rest, how to actually consolidate all of the equation to get your answer, right? So it's good if you have enough practice, so that you will notice that how to convert or relate, so that, because here we, in the end, I just want to relate between F and P, but the intermediate one is Cx and Cy, right? So how to do that when how to get Cx and Cy in terms of P, so that it could also as F, right? So this is what we have done. All right, so that's this question number 1. We'll move on to the next question, question number 2. So this is the question number 2 for today. The compound beam is pin supported at B and supported by rockers at A and C, as shown in the figure. There is a hinge or pin at D. Determine the reaction of all supports. Alright, so if you look at this diagram there, you should be able to identify that there are two members there, right? So it is critical for you to be able to identify which is the member, right? It should be straightforward, but I noticed from the past exams, some students seem to have difficulty to differentiate which one is a member, and suddenly they cut off at point B, etc. That's not correct, right? Because you have to understand, oh, that is one beam where there's pin there, right? So basically, you will have the longer on the left side there, and then the shorter on the right there, right? Basically, so you'll have A, B, D. Of course, this is D, C. Right? So you have some of the forces already. So there's forces here. There's a force here. Okay, it's to the left a bit. Anyway, there's a force here with a certain angle of 60 degrees there. So this is 7 kilonewton. This is 6 kilonewton. This is 16 kilonewton. Right, so now you have to identify what is the support reaction. So here we have a normal force at A. At C you have also normal support. And then at B you'll have Bx and By. So for the dimensions, so we have 4 here, 4 meter there, 4 meter here, 2 meter here, 4 meter here, and then you have basically 1 meter and then another 3 meter, right? There's 4 and there's 3, so 3 and 1. Alright. So how many unknown do we have? Alright, so another one. So the connecting here, I haven't. So this is pin to pin, right? So if I have dx over here and dy over here, for example, so here should be opposite, dx here and dy here, going down. Right. So if you look at this free body diagram first, then you cannot solve because there's 1, 2, 3, 4, 5 unknown, right? But if you look at this, you have only 3. So you have 3 equations, 3 unknown, you can solve this one, right? So I label this, let's say this is 1 and this is 2, right? So from free body diagram 1, so if I take summation of moment about point D equal to 0, and if I take counterclockwise as positive, so taking moment about this point, so NC times 4, 3 plus 1, 4, and then it should be minus 7 sine 60 degrees, the vertical one, and then distance of 1 should be equal to 0, right? So from here you can calculate NC actually. Right, so let's take a look at the answer. So if my calculation is correct, NC is 4.5466. 4.5466 unit kilonewton. Oops. So this is one answer, right? Because the question asks for all support, reaction of all support, so NC is one of them. So you get this one already. Right, after you get this one, then you can solve for x and y. So for example, summation of fx equal to 0, then you have dx minus 7 cos 60 degrees. That's all, right? Equal to 0. So dx you can calculate straight away as well. So you will get minus 3.5 kilonewton. Wait, my assumption, is it correct? Sorry, 3.5 kilonewton. So you get 3.5 kilonewton dx, right? So if you do a summation of Fy equal to 0, you get dy, and then minus 7 sine 60 degrees, and then plus NC plus this one 4.5466 equal to 0. So you'll get 1.5156. dy will become 1.5156 kilonewton. Okay. So after you have obtained this, then basically you have already dx and dy. Hence, you only have 3 unknown here, 1, 2, 3. So you can solve for free body diagram number 2. So because dx and dy is already solved, so you can take summation of moment about point B, for example. Let me take clockwise as positive. If clockwise is positive, so this one is NA clockwise, so NA times 8, NA times 8, this one, and then dx doesn't produce anything, dy is clockwise as well, plus 1.51 1.5156 times the distance of what is this, 8, 10, 14. Okay, what else? We have these forces also, right? So plus 16 times the distance 4 plus 6 times the distance of 10 equal to 0. So from here you can calculate what is NA. So what is it? If the calculation is correct, please verify. It should be 2.863 kilonewton, is it? Okay, after that you can summation of fx equal to 0 perhaps. So you'll have bx minus dx. Dx is this one, right? 3.5 equal to 0. So bx equal to 3.5 kilonewton. Do you need to, oh yeah. So because this is support also, this is spin support, right? And then summation of fy equal to 0, so you'll have NA, which is this one already, 2.863 plus by minus dy is minus 1.5156, and then minus 16 minus 6 equal to 0. So by we can calculate to be 30.65 kilonewton. 30, interesting. Okay, so that is what you will have. So we have solved for NA, the support, BX, BY also support, and then NC also support, right? So we have finished with this question. Right, so As you can see, it's quite straightforward actually, right? So I think if you have good understanding about frame and machine, sometimes you will prefer that compared to trusses, because trusses, it can be longer if you have longer structure, right? Anyway, that's question number 2. Let's go for question number 3. So this is question number 3. Determine the force P needed to support the 30 kilogram mass using the Spanish Burton rig shown in the figure. Also, what is the reactions at the support hooks A, B, and C? Draw all the free body diagrams with corresponding equilibrium equation of equilibriums. Alright, so what do you think? Do you think this question is easy or difficult? If you have seen enough, or you have tried enough question involving a lot of pulley like this, you will notice that this is bonus question basically, right? Because it is so easy. It is so easy, right? So first thing first, draw the free body diagram, right? And what we need to find, right? So in the end, what we need is, what is P? Basically, what is force in hook A? So for example, FA, FB, FC, right? Alright, so if you look at from the top there, right? So if you have the pulley here, where you have force P here, and of course this is the same cable, so it's still P, and then up there you can say you have FA, right? On the right side there you have another pulley there, and then this is the same cable, right? So this is still P, and then this is still P, right? It's still cable go around, and then this is FB, and then you have a bigger one here, right? So we'll leave that one first. So this one is actually linked to a pulley here, right? Where this is P from this one, and then this is P here, and then it goes here, right? So all this P connected to the same cable, and then you have one force downward. Let's use T for tension, right? And then this goes to a bigger pulley down here, where this will be T, right? This is the same cable, and goes up T to here, right? So you have T here and also T over there, and then this is FC, right? Sorry. And then T is going up here as well, right? This is all the same cable, and then this is, what is the mass? 30 kilograms, so 30 times 9.81. Now, after you have established the free body diagram, it should be clear that it is not as difficult as you might imagine, right? So we start with where we have the number here, right? So see here, if you do summation of Fy here, then you'll have T plus T plus T minus 30 times 9.81 equal to 0. Is it still okay? So basically 3T equal to 30 times 9.81, right? So T is basically 98.1 Newton, right? So after you have known this one, then you can solve here, right? So summation of Fy here, then you have P plus P plus P minus T, which is 98.1 equal to 0. So 3P is 98.1. P is, if you divide it by 3, 32.7 Newton, right? So now you already know what is T and P. Can you calculate for FA, FB and FC? You just summation of Fy, right, equal to 0. So for example, for this one, so you'll get Fa minus P minus P equal to 0, right, originally. So what you already know P here, right, so because Fa equal to 2P, Fa equal to 65.4 Newton, right? Then if you calculate for Fb, you should get the same, right? Of course, you have to show all the calculation to get all the marks, because that's the steps. Equation of equilibrium for this free body diagram, equation of equilibrium for this one, and then you calculate to get. And then FFC as well is just 2t, right, in the end. Of course, again, you have to show the summation of Fy equal to 0, and then the full equation, and then you get what is Fc there. Fc is twice of this one, right? So 196.2, is it 196.2? All right, so that is it actually, right? So it doesn't even take long. So yeah, every time you see any pull equation, actually, if you have enough exercises, you'll know that it's quite straightforward. All right, moving on to the next question. So this is question number 4. You have the diagram on the right, and then the question says, the direct in the figure is connected to pivot at A. Determine the largest mass that can be supported by the direct if the maximum force that can be sustained by the pin at A is 20 kilonewton. Draw the free body diagram necessary. Hint, the member AB is under compression. That should give you a way, right? That should give you, meaning that hint should give it what you should do, right? When you say it is under compression, what does it mean? First and foremost, even if there's no hint, you should be able to tell that AB is a two-force member, right? The hint even emphasize on that when you have tension or compression, that is two-force member, right? So with that, because if you know two-force member already, meaning that the member AB, and it says under compression some more, so it will be like that, right? So that's the implication. It is under compression, right? So if you know this already, then the diagram should be straightforward, right? So let's draw the free body diagram. So you take the whole thing there. I think this thing here, okay, is it long enough? There, and then because you have this two-force member, right? So you have force here already at the center of the wheel there, right? So because you have something like this, oops, and then you have two forces downward, right? So here and here, which is the same cable, and then it goes here. That's the same cable as well. So it goes to TD, because this one goes to D, right? So if I label it TD, this is TD, this is TD. This is F, what is this? Well, we call it FAB, right? So this is FAB. Okay, and then you have another wheel here, another pulley, right? And then you have several cables there, and then that is from C, so you'll have TC here, goes around TC and goes back here, TC, right? So based on that, what do you need? Okay, the angles are okay, this is all 60 degrees, right? Because it's given down there, so it's zigzag there, 60 degrees. And then what okay, the question asks for the mass, right? The largest mass. So TD going down, so if I'm drawing the free body diagram down here, it's basically like there's a smaller pulley there. So basically what you have is, this is the weight or mass times gravity, and then you have both TD and TD, right? Okay. What do we need? Okay, so I forgot about the number, right? So because this is all the free body diagram, but we actually are given the number. It says that the maximum force that can be sustained at pin A. So meaning that, because this one is going to the pin A, right? So this is connected to pin A, and that is the maximum that it can go is 20 kilogram. 20 kilonewton. Sorry. Meaning that if this is 20 kilonewton, FAB is 20 kilonewton, right? So we can use that value, right? And notice that what we want is just this mass, right? Is it mass? The largest mass. So we want M. So we only need TD. I don't care about TC, right? So if I use this free body diagram and do summation of Fy equal to 0, this doesn't have any Y component. So I will have, like, for example, 20 sine 60 degrees for this one going up, but this one is minus TD sine 60 degrees, and then minus TD equal to 0. Then from here you can calculate TD equal to what, right? So based on this, okay, so if I do step by step first, so sine 60, and then 1, and then 1, so you get 2.866 TD equal to 20 times sine 60, 17.32. So TD equal to 17.32 divided by 2.866. So you get 6.043. That is TD. Based on that, then you can calculate for W, right? So from here, summation of Fy equal to 0, TD plus TD minus mg equal to 0. So from here, m is basically TD plus TD, right? So this one here, so 6.043 multiplied by 2 TD plus TC, and then divide by 9.81, you'll get 1.232 kilogram, right? And then you go, that's the answer already. So it doesn't involve in great length of calculation actually for this one, because what we want, we don't even need to calculate for TC, for example, right? So make sure you understand what the question wants and what is the shortest possible. If you manage to establish free body diagram and understand what the question gives, for example, hint like this, it can be very straightforward actually, the question. Alright, so that's the question number 4. Moving on for question number 5. Alright, this is question number 5. Yet again, we have a lot of pulley. So the principles of a differential chain are indicated in schematically in figure 4, this figure there on the right. Determine the magnitude of force P needed to support the 400 Newton force. Also, find the distance x where the cable must be attached to bar EB so that the bar remains horizontal. All pulleys have radius of 60 millimeter. So we will start with the free body diagram, and we will start where we have the value there, right? So on the left side there, you have something where for this pulley here, you have force upwards, right? And then you have something here as well, force upward, right? And then you have 400 Newton here. So let's label that T. Alright, so based on this, it's straightforward if you want to calculate. So okay, I'll calculate straight away. So summation of Fy equal to 0, T plus T plus T plus T minus 400 equal to 0, T equal to 100 Newton. Then going to the next free body diagram, right? So we'll have on the right side there something like this. So here you have P, and of course P going there as well, right? And then going to another pulley going here, so another pulley, so another P here and P here, right? Is this enough space for here? I think we have to elongate. Never mind, it goes here, so it is P here, right? Right, 1 2 3 4 5. And then we have here, which is T there, 100 Newton. T equal to 100 Newton, and then you have distance of x here. It says that the radius is 60, right? So all of this is 60, 60. So basically this is 120, 120, 120, 120, right? Because 60 is the radius, so hence this is the diameter, 120. Okay, after you have established this free body diagram, then summation of Fy should give you straight away what is P, right? Because basically we'll have 100 from the T, and then minus P, minus P, minus P, minus P, minus P, right, equal to 0. So 5P equal to 100, so P equal to 20 Newton. That's answered, right? But what about X? So you have to have moment about point A equal to 0. So if I take counterclockwise positive, so you have 100 from T, 100 times X, and then minus 100p, 120p, and then minus 240p minus 360p minus 480p equal to 0. So if the calculation is correct, then x equal to 12 millimeter. Alright, so yet again another question based on pulley, and as you can see, when you have a lot of pulley, the calculation tend to be simple because all of this is become the same force, the same tension, right? Alright, so that's question number 5. Moving on to question number 6. Now in this question we have the diagram on the right, and then the question says refer to the structure shown, determine the support reaction at A and E, and then draw the free body diagram of each of the 3 members, and then determine the horizontal and vertical component of reaction at pin D, and the horizontal and vertical component of the reaction at pin B. Alright, so there are something specific that is requested in this question. So yeah, we'll just follow what the question wants, right? So part A, basically it wants support reaction at A and E. So in this case, you have to take it as a whole, right? So basically as a whole, something like that, right? And then you have force and force, 300 and 600. And then at A is somewhat of a rocker, so and A at E is basically EX EY. And then you have 1.5 meter. This one is 2 meter. Oh, sorry, 3 meter. Two meter, right? So this is 2 meter, this is 2 meter, is it? 2 meter, 2 meter, 3 meter, 1.5 meter. Alright, so based on this, we can calculate, for example, NA by taking summation of moment about point E equal to 0, right? So let's take counterclockwise positive. So with that, you have NA times 3. And then this one become minus 300 times the distance of 4.5. And then 300 here clockwise, also 600 clockwise, plus 600 times 2 equal to 0. So NA3 600 to 300 4.5. So if you calculate this, if my calculation is correct, so you get 850 Newton. Having established that, then the rest is just x and y, right? So summation of fx equal to 0. You'll have EX plus NA, which is 850 minus 300 equal to 0. EX equal to minus 550 Newton. Right, so meaning that it is not in this direction, it is actually left direction. Just note it as such, you are okay. Summation of Fy equal to 0, then you'll have EY minus 600. So EY equal to 600 Newton. And that's the answer, right? It's because the question asks what is the support reaction. So it is NA and EX and EY. Alright, so this negative means it's the opposite direction. That's all. Okay, so that's part 1. What about part 2? Draw the free body diagram of each of the member. We have space. Alright, so one member is something like this, right? And then you have the bar here, and then you have the horizontal, the vertical one there. So for this one, because we have already calculated this one first, so you can actually put, right? So this one EX is to the left 550 Newton, and then upwards, it's upwards, so upwards 600 Newton. And A is affecting this one, right? So this one is 850 Newton. The rest is the interaction between members. So at point C first, at this point C. Okay, so let's say this is Cx and then Cy, so meaning this should be the opposite, so Cx Cy, and then at point D, so for example dx dy, it will relate to this one, right, the top one here. So this will mean the y is over there, the x is over there. And then at point B, bx by, so this should be corresponding, so bx by, and then you have force here 300, 600. So that is the second part of the question. Draw the free body diagram. You have 1, 2, 3. Of course, what is missing is the dimension. So because this is 2, this is 2, this one is in the middle, right? So this one is 1.5, this one is 1.5. So this is 2 and 2. Okay, the bottom one is 1.5, is it? This one is also 1.5 because it's in the midline, right? Okay, based on this, because what we need is just dx and dy and dx and by. So only those that we are interested in, right? Bx by, dx dy. So we are not interested in anything else that much. So if I put the number, okay, this one is already established, right? Because it's to establish all of these numbers. So I can erase. So if I take this free body diagram 1, right? So free body diagram 1, if I take summation of moment about, because when is D and B, right? So take summation of moment about point C equal to 0. If I take, okay, based on this, by will be 0, right? So that's the final answer already. Alright. So what else? So if I do the same, because here by is already 0, so if I take a look at free body diagram point 2, this one, because by is 0, then I can calculate for summation of fy equal to 0. Then okay, everything downward. So this one is, what is this? This is dy, right? So dy going down plus by, which is 0, plus 600 equal to 0. So py not py, dy. So I'm so sleepy already, so I cannot think straight. Equal to minus 600 Newton. Okay, so meaning this just mean the opposite direction, right? So we need D and B, right? So D and B. So dy is already settled, by is already settled. If I'll take a look at this free body diagram. So if I take summation of moment about point D equal to 0, but here, so I can calculate for, if I clockwise as positive, so I can calculate bx times 1.5 should plus 300 times 3 equal to 0. So bx is negative 600 Newton, right? Bx. So that's just the, so that negative is just the opposite direction. So if this is established, I can calculate for dx. So summation of fx equal to 0. So minus dx minus bx, but this is minus 600 just now, minus 300 equal to 0. So dx equal to 300, is it? Yes. So there you go, another question solved. So in this case, you don't need to use any or every single free body diagram, because what you need is just 4 unknown, right? So dx dy and bx by. Alright, so moving on to the next question. Okay, this is question 7. So you have the diagram there, and the question says, refer to the structure shown in figure 4, or the figure shown. Part A, if a force of F equal to 300 Newton is applied to the handle of the toggle clamp, determine the resulting clamping force at A. All necessary free body diagrams must be clearly shown for the calculation to be considered. Yeah, so the question actually specifically mentioned that you have to draw the free body diagram for your calculation to be considered, right? Because some students actually straight away go to the equation, right? So you have to draw the free body diagram. And then part B, if the handle is shorter than the original handle, what will happen to the force F that needs to be applied to produce the same clamping force at A? Why? Okay, so for this question, for this type of question, I think from the previous experiences in observing how students answer the question in the final exam, normally question like this, when they look at the diagram of the question, normally straight away many students, you know, they become put off and says, okay, this is too complicated and I don't want to answer this, right? So because many of the answer paper come in blank at the final exam when question like this comes in, right? But I think if you have watched the lecture video, we have shown how to draw the free body diagram, and it is not as complicated as you might think, right? So do some practice and you will see that, okay, this is not as complicated, right? So moving on for this question, what color do I have? Okay, so first you have to draw the free body diagram. So you have to identify what is the different bodies that you can consider, right? Because you have to take away, normally when you have pins, you just detach the pins, right? So now if I go from the left side, right, so basically you have hopefully you can imagine how the things function, right? So when you looking at the diagram there, when you press at F, then the handle tend to go in the clockwise rotation, so it will actually push up at point C there, it will push up point C. In that effect, if it pushes up point C there, then it actually because there's a point D there as a hinge, it will actually, how to say, it will actually, because it push up here, it basically push down here, right? And it will actually clamp at point A. The block A is being clamped, is being pushed down, right? So at the end there, block A here is being clamped, right? So by this thing here, right? So you have something like this with the whole thing. Okay, I'll just draw like that, right? So this whole thing will clamp this one, right? So and then that is attached to, okay, do I have space here? Okay, this thing here is attached to, okay, so if I draw the handle here, something like this, right? Okay, there's not enough space there. Okay, so something there, and where we have the force F here, right? Is this clear? Right, so I'm sorry that, because I want to save space here for calculation, so And then this, you have to also notice that there's two force member there, right? This is the member BE, right? This connected here, right? And this connected here. And the base there, where here you are connected to base, the base is not important because that's just bolted to the ground, so you can eliminate that one. And okay, so these are the members that you have to understand. And okay, I'll use another color. So from this clamp here, let's say this is FA, that is clamping on block A. So obviously this one corresponding to this one, right? Hopefully it's not too small, you can see, right? So this force corresponding to this clamping force A, right? And then if you go here, okay, moving from point F there, so this one, okay, first this one first. This is two force members. So when you have two force member, you should understand by now it is either tension or compression, right? So it's along this line of action. So in this case, logically, if you understand that this is being pushed down there, this must be pushing this, so this must be in compression, right? Logically. So you can assume, or logically it will be that way. So let's name this FBE, because it's along BE. So corresponding to SBE here, it goes to this point B here, where you have it's around 30 degrees, right? Okay. You have FBE here, right? Where basically you have the angle of 30 degrees there, right? Okay, that is point B. Now at point C here, this point C corresponding to this point C, correct? Okay, I'll put it here because we have to have a line there. Okay, so at point C here, you will have X and Y component, right? So you can guess because it's rotating that way, this counter, so logically this is an assumption, right? But it's basically a logical assumption, so that you want to try to get the positive value there. So if you assume in this way and in this way, so this will be corresponding, right? So CX, CY, right? Hopefully by now also you have understood how we draw corresponding points, right? So for example, this point C, so if CX is to the right, CX must be to the left here. What is this? This is X. And if CY downwards, CY have to be upwards there. And then we have another point, which is point D here, which is straight away under point C. Make sure all those lines also is consistent. So here you'll just assume, let's say, dx like this and dy like that, right? So all of these are the forces that you have. Anything missing, here you have C and D, you have two force member, this one, right? What is missing yet is the dimensions. So I'm okay, my black but marker is all finished, almost finished. Okay, so what is the dimension? So this one is 60, this distance is 60 millimeter. The length is 235, so meaning this length here until this point is 235 millimeter. So that's for this one. This one, you have 70 millimeter for this one, 70 millimeter, and between B and C is 30, right? So this distance is 30, and then you have this length here of 275, right? Then those are the free body diagram that you need to be able to draw, right? So in the final, all of the elements that need to be in the free body diagram must be in the free body diagram for the full marks, of course, right? So you have the outline of the bodies, and then you have all the forces, all the unknown must be labeled properly, and all the known must be labeled as well. So we actually have one unknown forces, right? Right now all of this is unknown, but the question actually said if a force F equal to 300 Newton is applied, right? So this F here is equal to 300 Newton, right? So in the free body diagram, the known force must be also known. The number must be there, right? What else? So the rest is unknown, right? So all the angles, dimensions must be there as well. All right. So based on this, can we solve? How many unknown do we have? 1, this is FA, 2, 3, same, 4, 5, 6. So you have 6 unknown, you need 6 equation, right? So basically you need 2 free body diagram which give 3 equation each, right? So here you have 3 equation, Fx, Fy and moment. Here as well you have 3 equation, Fx, Fy and moment. Hence you get 6 equation and 6 unknown can be solved, right? This one this one is just this equal to this, same here, right? So you do not have any equation to use here. All right. So where to start first, right? So we know that we start normally from the value that we have, which is here, right? And then we want to transfer all the value here to get to Fa, because the question says what is Fa when this is 300 Newton, all right? So what is important is just, okay, this is the important thing, because when I get here I can this one, and then from here I can calculate this one straight away, for example, right? So that's the only important thing that I want, right? So meaning that if this is if you can foresee what you need, right? If you take moment about point D, you can calculate this one provided that you know Cx, right? Because why? Because Cy actually goes through the point and it doesn't create any moment, right? So I just only need Cx, for example, right? But of course to get here is the easiest way normally is just to solve this one first, because we take moment about this point, you get this, and when you get this you can calculate actually this one using Fx and Fy. Alright, so I have to label it properly so that when you draw the equation, you know it is corresponding to which free body diagram, right? So let's say this is 1 and this is 2. So from free body diagram 1, let's say I take summation of moment about point C here equal to 0, and let's consider counterclockwise as positive, right? So this one, if the vertical one, it will be counterclockwise, so FBE cos 30 times the distance of 70 millimeter, right? This counterclockwise, so positive, and then the horizontal one, it will be clockwise, so minus FBE sine 30, and then the distance will be 30 there, 30 millimeter, and then you have another force F there. F will create counterclockwise. Okay, F also have F should have also the angle, right? So the angle is missing here, so in terms of free body diagram, I didn't notice that. So this will be 30 degrees, right? Yeah, okay, that is based on this actually. This is 30 degrees, hence that is 30 degrees, right? So F also have X and Y component, right? So if I take the X component first, horizontal component, it will produce clockwise. Yeah, so minus which is 300 Newton. The horizontal one is meaning sine 30 degrees. So the distance will be this height here, which is 275. The height sine 30 degrees, right? And then taking the vertical component of that force going down, it is another clockwise, so minus again, so 300 cos 30 degrees, that become the vertical, and then the distance is the whole thing here. So that's where some student might got confused. What is the distance? So the distance is basically 70 plus the remaining here, right? This one is actually 275 cos 30, right? So the distance is the whole thing, 70 plus, so 70 millimeter plus 275 cos 30 degrees. Right? Then all of this equal to 0. Hopefully this is clear, right? Now, all of this is actually quite straightforward and not difficult if you understand what is going on, right? It's just force times distance, right? And normally, as we have learned from earlier chapter, we resolve every force in horizontal and vertical, horizontal and vertical. So for example, FBE, horizontal and vertical, F is horizontal and vertical, and then you just multiply by the perpendicular distance. So vertical perpendicular distance 70, horizontal vertical perpendicular distance is 30. Horizontal perpendicular distance is the vertical one, so this one sine 30. Horizontal vertical, so the distance is the whole thing, so this plus this one, right? I noticed some students, they do not understand the basics, so when they look at this, what is this now, it's complicated. So it's not actually complicated, it's just you just add the distance, that's all, right? So make sure you understand the fundamentals to make sure that you understand what's going on here. So if you have this one, then you can calculate straight away, right? Because from all of this, the unknown is FBE, so you can calculate FBE equal to something, and if the calculation is correct, 2207 Newton, 2207 Newton, right? So that's double check of course in your calculation, right? So if you have already this one, then you can calculate for Cx, right? Enough space, right? Can I do this one? All right. So based on that, I can do summation of Fx equal to 0 for still using free body diagram 1, right? And then you have Cx, this is this one, and then you have horizontal was this one, so this is negative, so minus FBE is this one, 2207 sine 30 degrees, and then that force there also have horizontal, right? So it's to the right, so plus 300 sine 30 equal to 0. By the way, I think some students actually confuse how to get this 30 degrees, right? Hopefully you understand why, right? Because okay, how to say, where to show here, okay, because when you have some slanting line like this, right, when this is 30 degrees and then you have a perpendicular thing there, right? So one way to illustrate is basically if you have this zigzag, this must be 30 also, right? 30 must be 30. So if this is the case, because this is 90 degrees, so this must be 60 degrees, right? And if you have a perpendicular line here, of course this is 90, so this is 30 back, right? So this is 90, this is as well 90, right? So if I draw the angle this one, it will be 30. If you want to draw this one, it will be 60, right? So make sure you understand how to relate angle here to angle here, right? Yeah, so this is basic trigonometry, because if you make sure you understand, do not guess, right? Because some students, when they start already have a lot wrong angle there, so it will affect this whole calculation here, and it will affect the whole calculation here, calculation here, calculation there. It will affect everything. So make sure, do not assume, make sure you really understand what's going on. From this one, so you can calculate Cx equal to, so 953.5 Newton, right? Again, check everything in terms of calculation, because most of my calculation I do ad hoc and in a rush before I can record these videos and publish, right? So as for previous videos as well, when you look at the comment section, sometimes some mistake is being pinpointed, right? So it can happen, right? Especially when I'm doing this in the middle of the night and I make some mistakes. So double checks. In terms of the numbers, in terms of the methodology, inshallah it's consistent, but sometimes I make mistake in terms of calculating. All right, so Okay, so based on this, you can also calculate Cy, right? Of course, if you do summation of Fy equal to 0, you can calculate Cy. But as I mentioned earlier, because what we need is just Fe, and if you already notice, if I take moment about point D, so now, okay, I'll go straight there. Maybe I'll put there, right? Because we have the free body diagram, you do not need the original diagram anymore, right? So, based on free body diagram, so from free body diagram 2 here, if I take summation of moment about point D equal to 0, right? About point D here, and if I take clockwise as positive. Now, some of you might ask, why suddenly counterclockwise, clockwise? It's up to you. But normally, because I want, for example, this to be positive, for example, so I follow that. For this one, I think it's counterclockwise, so I take counterclockwise as positive, so that it becomes positive here. And that one, because I want Fa, is the final answer is Fa. I want this to be the positive one, so I just take clockwise as positive, right? Regardless, if you take clockwise or counterclockwise, the answer will be the same, right? Okay. So if I take clockwise there, so Fa is clockwise, so Fa times the distance of 2, 3, 5. This distance here, right? About point D, okay. This dx dy, of course, no moment, is that point. Cy also goes through the point, so no moment. So Cx, this is counterclockwise, so minus Cx. Cx now is this one, 953.5. And then the distance of 60. This is equal to 0, right? Because that is the only force that produce moment about point D. So from there, Fa equal, if you calculate, you get 243.45 Newton, right? Or basically 243 Newton. And that is your answer, because the question only asks for what is force at A, right? So as you can see, if you can correctly draw the free body diagram for this question, the calculation is not long, because you have one equation here, another equation there, right? You do not need to solve everything, right? You do not need to even calculate dx, dy, because the question specifically asks for here, right? So make sure you have at least spend 1 minute just to strategize, right? Okay, I need this one, so how to get from this value to this unknown here? So the value here is what I need. So if I get here, taking moment here, I can straight away get here, right? So but in this case, to get to this value, it's easiest to solve this one first, because taking moment about this point, right? So okay, I've solved this one, and then obtaining this one, I can solve for this one, and then having this value, I can solve for that one, right? So make sure you strategize if possible. All right. So part B, this is part A, right, for the calculation. Part B, it says, so if I put back the diagram, perhaps. Now it says that if the handle is shorter than the original, meaning this handle is shorter, what will happen to the force F that need to be applied to produce the same clamping force at A? So to produce the same force, is it in the light? Okay, hopefully you get the value just now. Anyway, so to get this same force here, but if this is shorter, what will happen to force F? Logically, from experience, I think you would appreciate that if you try to turn something, some nut, etc., right? If this is longer, you require less force, right? If this is shorter, you have more force to exert, right? To produce the same rotation, right? So it's the same concept here, right? But of course, when the question say why, you have to actually elaborate why, what happened there, right? You cannot say from my experience I think like that. You cannot. So from here, if this is shorter, meaning this is shorter, right? 275 is shorter. To produce the same value of Fa here, of course, Cx must be the same. because this one is providing this one. So for Cx to be the same, this 2207 must be the same, so FBE must be same. To get this the same when this value is lower, you need higher of force, right, basically, to get the same here, right? So that's the understanding from based on the calculation that we have done, right? So yeah, logically, to produce the same forces throughout, when the distance is smaller, to get the same value, the force must be higher, right? So anyway, so that's the idea. So whatever way you can express to the answer script that can be understood, that you understand what's going on, you will secure the marks, right? All right, so that is question 7, I think. We will go into question number 8 right now. Okay, this is question 8. You have the diagram on the right there, and the question says, consider the pruner shown in the figure. Determine the force P that need to be applied to generate a cutting force of 260 Newton at A, assuming that the contact surface at A is smooth. Right. So another question, where when it comes to the final exam, when this come out, the student, when they just look at it, they actually become scared. I think that many of the answer script is empty for this question, right? So I noticed that many questions in machine especially, it seems complicated unless you understand and you know how to do. It's actually fairly simple, just like the previous question, right? So we will see this question. It's quite simple when you understand how to solve, but if you never attempt, you never try, it seems complicated. So make sure you have tried this kind of question on your own to see that it is not complicated, not difficult actually, right? All right, so what we have here is a pruner or something like a plier, something, right? So you have clamping force at P, meaning the applied force at P, and that it will provide clamping force at A, right? So first thing first, you have to draw the free body diagram, right? So make sure you have seen things like this before, so that you can know, okay, this is one member, this is another member, this is another member, right? Because I noticed some students, when they draw, maybe they have never seen things like this before, right? So they do not know how to disassemble, right? So how to disconnect this one, is this? So hopefully you have seen something like this, right? Okay, so just the bodies that we have, right? So one, we have this thing over here, right? The dark gray thing there, right? And then that is attached to the bottom part of this one, right? So this is something like this, and then okay, in terms of the length, this is not consistent, so I have to shift here, right? So it is something like this, and then it goes something like this, right? Something like that. That's the handle one side there, and it is connected to, okay, do I have enough space here? So I have to draw here. So connected to this handle here, something like that, right? And then you have actually this member here, right? Connecting DE. All right. So that is the 4 members that you have, right? So this one, the black one. So this one, this handle, and then this one, and then the bottom, the lower handle there. All right. So that's the first skill that you have to be able to do, right? Just to draw the members first, and then you draw all the forces that is there, right? So you have the force P here and force P here. Okay, that's given. Okay, the question says, what is the force P? Okay, another one, if you want to include, is the pin there, or is what is it? Whatever is being cut there, right? So in the middle here, so you have something like that in the middle that is being clamped by this part and this part here, right? So if you go there, so this will be clamped, right? So this will be clamped, will be cut at point A. So the value is given. So the question says, what is force P to produce 260 here? So 260 Newton, 260 Newton there, right? So this thing here is attached to this one, right? So the cutting on the top here is here, so this is the corresponding 260 Newton, and then here, right? So this is the corresponding 260 Newton, right? So because this is downwards, this upwards, this become downward. Hopefully you understand that concept by now. All right, so you have actually two force member here, right? DE, this is two force member, and from the mechanism you can understand that, okay, this must be in compression because it's being compressed in the middle there, right? So if this is like that under compression, and we label it FDE, for example, DE. Now the top part here is actually connected to this point here, right? Somewhere here, right, at point E. So it have an angle of 45 degrees, so it's something like this, and we have FDE here, right? And then it has an angle of 45 degrees, right? So that's this point here. This point down here connected to point D here, right? Somewhere there. So it will be like this. Corresponding to this one, it's this one, FDE. So this is also 45 degrees. Alright, what else? So here you have point C, right? Point C here. It's the same line, right? Make sure things that have the same line, it's clear it's the same line, right? So this is point C connected to a point here, right? Somewhere here, point C, right? Yeah. So we'll have to assume the direction, right? So if I assume like that, right? Of course, you can assume correctly because logically, because this is to the left, this must be to the right to counter, right? And if you have moment about this one, this is creating the rotation, this must counter, right? So you can guess that way, right? So CX, CY. So based on this, it will be like this, right? Correspondingly. So this is to the right, this becomes to the left, this is upwards, this become downwards. Then you have another point, point B, where on this one is on top of this one is one line somewhere here. Point B connected to point B here, right? So it is not the same line. It's have, if you notice carefully, look between point B and point E, because B and E, there's a distance there, right? Which is the 10 millimeter, right? So okay, so what to so we'll just assume, right? So for example, this is this point B, right? Assume BX here, for example, and BY there, for example. So in that case, if this is BX to the right, so BX must be to the left here. If BY upwards, BY must be downward here, right? Correspondingly. Okay, what about all the dimensions? So what color can I use? Okay, maybe I'll use the blue one still. Okay, down here first. This whole length is 150, is it? From C to P is 150, right? So this whole thing is 150 millimeter. And this distance here is between D and C. Yeah? This is 25. Alright, and this is the same level. Alright, so that's settled. This one, between A and C, this is 60, and between C and the rest is 150, right? This one 160, 150, sorry, 150. All right. You have also to have this height, right, between B and C. It is actually okay. The height of B and C is not really given, right? This height, is it given? B and C. So okay, because what is given is 45 degrees. So you have this 45 degrees, and you know that is that is 30 between D and E. Where's D? D and E. Where's E? So wait, which one is I'm talking about? This one, right? C and B, right? So the handle, so it does take some calculation, but we'll leave that first. Do we need that? Do we need that? Okay, we will see. Here, okay, so here we mentioned that this distance there, where this is 10 millimeter, and then between B and E you have 55, right? Meaning between B and E here you have 55. Basically it's 25 plus 30, and then on this side here you have 60. Right. Now, if you calculate using this free body diagram, obviously you will need this distance, right? But let's take a look first. What do we need to find? Because we need to find P. So P can either this one or that one, right? Both of this P is the same. So if you get this, you get that, you get that, you get this, right? So the same there. And your value is from here, 260, right? So either starting from this 260 to get to that P, or starting from this 260 to get P, either that one or this one, right? So connecting this thing here to this is FDE actually, right? So from here, can I get FDE? Yes, I can, right? Because if you take moment about point B, you can get FDE. If this FDE is obtained, I get this one. Can I calculate P? You can, right? Because if you take moment here, then you can calculate there, right? So from there I can, okay, then I will use this too. So let me use this as my free body diagram 1, and this is 2, and this is 3, right? So if I use from free body diagram 1, of course I can say these things like this because I already label it, right? So if you have not numbered or anything, you have to number it first so that the examiner can follow what is going on here. Okay, so we have labeled the free body diagram. So this is 1, this is 2, this is 3. So I can start from free body diagram 1, right? So we have from free body diagram 1. Of course, I can make this statement after I have labeled the number of the free body diagram, right? So we can take summation of moment about point B equal to 0. Let's take counterclockwise as positive, right? So you have FDE here. You can resolve into horizontal and vertical. So if you take the horizontal first, so FDE cos 45 degrees horizontal, the distance will be 10, right? And it's counterclockwise, of course, positive. So if you take the vertical one, also counterclockwise, so positive FDE sine 45 degrees, and distance to point B here, right? Because we take moment about point B, so this is 55, right? And then we have another force that produces moment about point B, which is this one, right? So it is creating clockwise, so minus 260, and then the distance is 60. All of this, if you add, it should be equal to 0. From here you can calculate what is FDE. It equal to, so if the calculation is correct, it equal to 339.41 339.41 Newton, right? So sine 45 55, cos 45 10, okay, and then this one 60. All right, so do check. Okay, now we have already FDE, right? So meaning that we have obtained this one and this one. So the next step is, okay, I know, if I know this one, I can solve for P. So from free body diagram number 2, if I take moment, summation moment about point C equal to 0, about this point, and if I take counterclockwise as positive, then I have P here with the distance of 150, the whole distance here. And then this one, the horizontal component, it doesn't produce any moment, right? It goes to the point. The vertical one is clockwise, so minus vertical. So FDE is already given here, 339.41, and then sine 45 degrees. The distance will be 25. This must be equal to 0, right? This one minus that one equal to 0. So from here you can get P equal to 40 Newton. And that is the answer. Because the question simply asks, what is force P to produce 260? So from 260, I've calculated what is FDE. I can calculate for P, right? So that is if you want to use this calculation way, right? If you want to use this free body diagram as well, the answer will still be the same. For example, from here, after you get FDE, you also want to get FBX and BY. From BX and BY known, you can solve using this free body diagram as well to get P, right? For example, taking moment about point C, you know already BX and BY, you can calculate for P. You can test that one, the answer should be the same. But why do you want to go to the long calculation if you can use a shorter calculation, right? So that's coming from the 1 minute that you spent to plan before, right? So what is the possible way? So one is, for example, from here, the value that you know, okay, just to reiterate the strategy, right? When you think before, if you look at here, you cannot solve straight away, right? Because you have 1, 2, 3, 4 unknown. You have only 3 equations. No, I cannot start here. There's no way. But I can start here, right? Because 3 unknown, 1, 2, 3, and 3 equation. You can solve. So what do I want to solve? If I want to go to this point, I just need FDE. Because here you only have FDE. You do not have B here, right? So when you get this one, you can straight away calculate that one. Oh, so personally, I would choose that one, right? So I solve FDE, go this here. But you can also choose, okay, if I can calculate everything, I can also go here because when this is calculated, there's only 1, 2, 3 unknown. I can solve for this one. The answer will be the same. You can try, you can prove, but that's the way we solve machine problem like this, right? So if you notice, it is not long. You just draw the free body diagram properly, and then select what equation of equilibrium you need to use, apply, and you can solve. So for machine problem, normally it looks difficult until you actually know how to solve it, right? So that's the thing. So try to solve so that you know, and then it will not be difficult anymore, right? All right, so this is question number 8. Going for question number 9. Okay, this is question 9. You have the diagram, and then the question says, refer to the structure shown in the figure. Part A, draw the free body diagram of all 4 members in the frame shown in the figure. Part B, considering the 4 free body diagram drawn in part A, how many unknowns are there in total? Can the support reaction at A and E be determined? Explain the reason for your answer. Alright, so if you notice this question, it doesn't ask you to calculate anything. It just wants you to answer conceptually, right? So this is more of a understanding question. If you understand, you can do it. If you do not understand, you might not get the answer correctly, right? So the question says part A. Okay, we'll do part A first. Draw the free body diagram of 4 members. So can you identify all the 4 members? So one is from A to C, another one is from C to D, another one is from D to B, another one actually is that down from B downwards, right? So that's the 4 members there. Alright, so if you have to draw, so you'll have from A to C there, and then from C to D there, and then from D to B there, and then from B downwards there, right? Okay, basically that's the 4. And when you, okay, that's the body. So what are the forces? So when you want to draw the forces, what you need to check first is there any 2 force member, right? So can you identify any 2 force member? One thing that straight away is the vertical, this one, right? This is 2 force member, right? So when it is 2 force member, it's either in compression or tension, right? So in this case, B, this link here, logically is being pushed down, so it is under compression. So if you draw like that, it will be like that. For example, FB, right? FB. Of course, if this is under compression, and this link at B here, so correspondingly this will be FB, that is going upward, right? Okay. Is there any other 2 force member? Hopefully you can see that point CD is also 2 force member, right? This one. So if you assume it is under tension, so if you assume that way, FCD, so meaning that this one will be correspondingly there, right? FCD, and then this one is corresponding also FCD. It will be like that. What else? So you have the distributed loading there. So for the 900 Newton over meter here, so basically in terms of the value, it will be 900 Newton per meter times the distance of 6 meter, right? 6 meter length. So you got 5400 Newton, right? There. Of course, in terms of the distance, because when you draw free body diagram, of course you have to draw the distance. But first, you have also another force there from the rocker at E. So you have an E, right? So for this things here, in terms of the distance, so you have 3 meter here. How to draw? Okay, let me use blue one. This one is 3 meter, right? This is also 3 meter, but to the force here, it should be 2 meter, right? Because the distributed loading is 1/3 2/3 ratio, right? So 1/3 is 2, 2/3 is 4, right? So that's there. This one is just 2 force member. Okay, this one. So you have as well the triangle distributed loading. So you have 2 force here. So one is, oh wait. I make a mistake here, right? So this is a triangle. So I'm so sleepy. Okay, so it should be half there, right? So it should be 2700, right? Should be 2700 Newton, right? Okay, hopefully you notice that one. When I did that mistake, you say, what? That's a mistake. Alright, so here it should be half, then 900 Newton per meter, and then the distance is 3, right? 3 meter. So this one become what? It's half of that one, right? What will become? So 2700 divided by 2 is 1350, is it? 1350 Newton. And if you calculate this one, it's also the same, right? 1350 Newton. And then what do we have at A? This is a fixed support, right? So you have AX, AY, and moment, right? So moment A, AX, AY. For the distance, so it will be this 2 meter, 2 meter, 2 meter, right? Because for the triangle, it's 1/3 2/3 ratio, right? So this 2 meter over here, 2 meter over there. The whole thing is 6, so like that. Okay, so the first part is to draw the free body diagram, hence all of this. Hopefully you understand everything. Now, to answer the second part, it says, how many unknown? So unknown, number of unknown is what? So we'll start from here, right? So AX, AY, MA, all of these unknown. So 3. known. This is an unknown. 4, right? So 3, 4, same, right? So it's unknowns. 4. This one 5. This one 6. So you get 6. Right? That's the answer basically. 6. Now, you will not get 6 if you do not realize that this is 2 force member, for example. Because if this is not 2 force member, you will have xy, 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 right? So the number of unknown is more. So that will affect your answer if you do not understand that that is 2 force member. Right. So next question. Can the support reaction at A and E be determined? So can you solve all of this? Explain your answer, right? So this is related to, you have 6 unknown, equation is also 6, right? Why 6? You have 3 equation here and 3 equation here, right? Fx, Fy and moment, Fx, Fy moment, right? This one you don't have anything because it's just, if you apply Fx equal to 0, then Fc equal to FCD, right? So not helping there as well, right? So you have 3 and 3 there. So 6 equations, 6 unknown. So can solve, right? So if you do not know that this is 2 force member, you'll get more unknown here. So maybe you'll get whatever value here, and that's more than 6. Your answer will say you cannot solve because unknown is more than known, right? So that's where, if you do not understand that concept, it will affect your answer here, right? So that this question doesn't have any calculation, so it just ends there, right? So if you need, then I think you know what to do, right? So you have Fx, Fy moment, Fx, Fy moment there, solve, right? Alright, so that is question number 9. We'll go straight to question number 10. Okay, this is question 10. Alright, so you have the diagram there, and then the question says, the compound beam in the figure is fixed, supported at A. So meaning that A is fixed support, and supported by rockers at B and C. Meaning that B and C there is rocker. If there are hinges or pins at D and E, determine the reaction at the support A, B, and C. Draw all necessary free body diagrams. Alright, so basically you need to compute what is the support reaction at fixed support A, as well as at the rocker B and C, right? Yeah, so let's do it, right? So basically the first step is to draw the free body diagram. In this case, you have to combine with the understanding of distributed loading, right? So we have 3 members, right? So we have member AD and member DBE and member that EC something like that, right? Alright. So what do I have? So I'll draw the support reaction first, right? So for at A, you have AX, AY, and MA, right? Because it's fixed support. What else? Okay, so at okay, where do we start? Okay, so in terms of D and E, it's connected there. Alright, I'll start from the end there, right? Okay, so for this one, you have 36, because this is where you have the value, right? 36 kilonewton meter. So your calculation will start there, because that's the value that you have. And then you have a normal reaction of C here and C, and then you have force from the distributed loading. Do you know the value there? You should, right? So it's a triangle, so half times 8 kilonewton per meter times the distance of 9 meter, right? So 4 times 9 is 36 kilonewton, right? Okay, So point E is connected here, right? So if you assume this to be like that, for example, so this is what E, right? So EX and EY like that. So that would mean correspondingly, so EX will be like this and EY will be like that. Right? Next, here. So you have normal force, normal at B there from the rocker. And then you have the distributed loading, so at the middle there. So this one is simply 8 kilonewton per meter times 6 meter. 48 kilonewton. What else? So, and then point D here, right? So in this case, you can assume, for example, D, sorry. If you assume dx like that and dy like that, for example, so correspondingly, so dx will be like this, dy will be like this, right? So here you also have distributed loading, so it should be at the middle here. So 6 kilonewton per meter times 2 meter. So it is 12 kilonewton. So if you consider all the dimensions, so this is 1 meter, 1 meter. For this one, this is at the middle, so it should be 3 meter here. For this one, it should be 4. And this is 2, right? There, for the distributed loading, it's 1/3 of 9. Should be 3, right? So it should be 3 here. And this is 6 given. This is another 3. But that doesn't have anything there. Alright, so that will be your free body diagrams. Clear there? Hopefully. Alright. Now, you have to determine what? You have to determine AX, AY, MA, and B, and C. How many unknown do you have in total? 1, 2, 3, 4, 5, same. 6, 7, 8, same. 9. You have 9 unknown that you have to solve. Or in total, 9 unknown in total, right? Can you solve it? You should, right? Because you have 3 equation here, 3 equation here, 3 equation here, right? And so in total 9 equation, 9 unknown you can solve, right? So why so many? I don't know. That's just life, right? Okay. So where should we start? So obviously you cannot start here, right? Because you have too much unknown here. Here also you cannot solve. So you can only start here, right? Where you have 1, 2, 3 unknown. You have 3 unknown, 3 equation you can solve. Okay, so then I will label this free body diagram as 1, 2, 3. Right? So starting from free body diagram number 1 over there. Easiest way to start is summation of moment about point E equal to 0, right? Moment about point E. So if I take counterclockwise as positive, I have NC, so NC time a distance of 6, okay, it's counterclockwise, and then I have minus 36 there from this couple moment there, so it is minus because it is clockwise, and then I have another minus because this one is also produced clockwise, so 36 times a distance of 3. All of this should be equal to 0. Right, so from here you can calculate for NC, right? So what is the answer? 24. So this is one of the answer, right? Right, so because what we want is all of this at A, at B, and at C, right? So now this is solved. But we have to move on because we need Ex and Ey to solve for this one, right? So if you do summation of Fx equal to 0, this is still for free body diagram 1. You'll notice that Ex equal to 0, right? Because there's no other horizontal forces. And then if you do summation of Fy equal to 0, you'll get Ey, and then minus 36, and then plus Nc. But Nc is 24 there, right? Equal to 0. So Ey will be this 36 minus 24 is 12 kilonewton, right? Right. So you have Ex and Ey, then you can move from free body diagram number 2. Now we move here, right? Because we already have Ex, Ey. Now we can solve for these 3 unknown here, right? Right. So we want to solve for NB. So we can take summation of moment about point D equal to 0, right? Here. So if I take counterclockwise as positive, so what I have is NB is counterclockwise. So NB times the distance of 4. And then Ey is 12. So it's clockwise, so minus 12 times the distance of the whole thing is 6, right? And then you have this 48 that is also producing clockwise, sorry. So you get minus 48 times the distance of 3. All of this equal to 0, right? So from here you can calculate NB, and B equal to, and if you calculate, you'll get 54 kilonewton. Of course, verify the numbers. Right, so NB 4, 12, 6, 48, 3. Alright, so that is also one of the answer because we need to find NB. The rest is just to get dx dy, so we can go here, right? So if you do summation of Fx equal to 0, you have dx should minus Ey, but should minus Ex, but Ex is 0, so then it will be equal to 0. And then you do summation of Fy equal to 0, then you will have dy minus 48 plus NB, and NB is this one, 54, and then minus Ey, which is this one, minus 12, equal to 0. So 60, so dy becomes 6 kilonewton, right? Alright. Now, if you notice that I managed to get Ey positive, dy positive, because the assumption is correct, right? So that is where sometimes it's helpful if you can guess, right? Okay, logically, because this is pushing up, this must be pushing up as well to counter the moment, right? Similarly here, right? Something like that. Now we can go to free body diagram number 1. If I do there, is it clear? Because there's lighting there. Where should I go? Should I erase this one? Hopefully you understand this part already, right? So what's going on? But I would need, what do I need? I need dx and dy, so I need these two, right? So I'll erase this part here. Hopefully this one is understood already, right? So from free body diagram number 3 here. So what do I need to do? Of course, I have this one already. So if I do summation of Fx equal to 0, then I have minus Ax. Dx is what? Dx is 0. So Ax is actually equal to 0. That's one of the answer, right? And then summation of fy equal to 0, you have ay, and then minus 12, and then minus dy minus 6 equal to 0, right? So ay equal to 18 kilonewton, one of the answer. And then if you take summation of moment about point A equal to 0, then if you take counterclockwise, of course, so because I assume counterclockwise, so MA, and then minus 12 times 1 from this one, 12 times 1, and then also minus dy is what? 6 times 2 equal to 0, right? So 12 times 1, 6 times 2. Then MA, you will get 12 plus 12, 24, is it? 24 kilonewton meter. Of course, this will, because the assumption is correct, counterclockwise. So you get positive. And then all is solved, right? So you have already solved NC, NB, and AX, AY moment of A. Right, so I'm not sure if you noticed the frame question, even though it looks simpler, can be longer than machine problem in terms of the calculation, at least, right? For the machine, the tricky part is just to draw the free body diagram sometimes, but once you get the free body diagram, sometimes the calculation is quite short actually, depending on the mechanism as well and what is the question one, right? Because here the question one, a lot of things. You have to find a lot of things. But for machine, sometimes they just only ask for one unknown, right? So that's a way to get it short. But anyway, so that is question number 10. Alright, so that is the end of the tutorial questions that we have to cover. So basically those are the questions for frame and machines that have come up in the final exam for the past several years, right? So I'm not saying that this semester or your semester you'll get the same question. It depends, but hopefully if you understood all the concepts and how to apply the equations and the concepts and the free body diagrams, you should be able to solve any question that you need to solve, right? So I think that's the end of the tutorial today. Hopefully it has been helpful for your understanding and ability to solve the problems. With that, we end the session. Inshallah, subhanakallahumma bihamdik, ashhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Hopefully it has been helpful. Hopefully you understood, and hopefully it will help you in your exam especially. And also this understanding is it can be applied throughout your career, of course, right? With that, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.